What if the largest planet in our solar system vanished, instantly, without warning? No explosion, no flash of light, just gone. The night sky would look almost the same one at first. But beneath that calm surface, the solar system would begin to unravel. This is not a science fiction tale about an alien invasion or a magical spell. It is a thought experiment rooted in the fundamental laws of physics and gravity. We are about to explore a hypothetical scenario that reveals the intricate, often unseen balance of our cosmic neighborhood. Jupiter, the colossal gas giant, stands as a sentinel in our solar system. It is a world of swirling storms and immense pressure, a planet so vast it could swallow all the other planets combined. Yet, its presence is felt far beyond its swirling clouds. For billions of years, Jupiter has played crucial roles that are integral to the very existence of life on Earth. It acts as a gravitational shield, a cosmic vacuum cleaner, and a stabilizer of planetary orbits. Its influence is subtle yet profound, shaping the destiny of every body within our solar system. But what if this titanic guardian simply disappeared? If Jupiter, with its immense mass and gravitational pull, were to vanish tomorrow, the consequences would be nothing short of catastrophic. The immediate aftermath would set in motion a chain of events that could irrevocably alter the fate of Earth and every other planet. Jupiter's sheer size gives it an unparalleled gravitational influence. More massive than all the other planets put together, it dictates much of the dynamic choreography of our solar system. Its gravity extends its reach across vast distances, shaping the paths of comets and asteroids far beyond its own orbit. This immense gravitational pull establishes Jupiter as the solar system's gatekeeper. It stands watch over the inner planets, including Earth, from the chaotic outer reaches. Without this giant, our corner of the galaxy would be a very different and far more dangerous place. One of Jupiter's most critical functions is its management of asteroids and comets. It acts like a shepherd, guiding and containing countless celestial bodies within the asteroid belt and beyond. Many potentially hazardous objects are either captured into stable orbits around Jupiter or flung harmlessly out of the solar system. This protective role is vital. Jupiter prevents a constant barrage of space debris from impacting the inner planets, particularly Earth. Without Jupiter, many objects that would otherwise pose a significant threat would find themselves on new, perilous trajectories. Think of the numerous impacts Jupiter has absorbed throughout history, saving Earth from potential havoc. The most famous example, Comet Shoemaker-Levy 9 in 1994, dramatically demonstrated Jupiter's role as a cosmic catcher's mitt. That impact was powerful enough to temporarily scar Jupiter's atmosphere for months. Beyond simply deflecting space rocks, Jupiter also plays a key role in stabilizing planetary orbits. Its massive presence helps to maintain the delicate dance of planets around the Sun, keeping them on relatively predictable and stable paths. This gravitational tug-of-war ensures a long-term consistency in orbital mechanics. This stability is crucial for all the other planets, especially for Earth. Our planet's stable, nearly circular orbit is a prerequisite for a consistent climate and the long-term evolution of life. Without Jupiter, this harmonious ballet would begin to falter, leading to unpredictable and potentially devastating changes over time. The first and most immediate consequence of Jupiter's disappearance would be a dramatic change in the asteroid belt. This vast region between Mars and the former orbit of Jupiter would become a much more dangerous place. Asteroids that were once held in check by Jupiter's gravity would suddenly be set free. Their stable orbits would be instantly destabilized. These space rocks would begin to scatter in every direction, no longer bound by the gravitational influence that kept them largely confined. Some would be flung outward, while others would be nudged inward, directly toward the inner solar system. This would lead to a skyrocketing impact frequency on Earth and the other inner planets. We would no longer have Jupiter as our shield, and the constant barrage of space rocks would begin. While not instant cataclysm, the likelihood of major collisions would dramatically increase over time, measured in millennia rather than millions of years. The potential for devastating consequences from such impacts is immense. A large asteroid strike could instantly wipe out entire cities, triggering tsunamis that devastate coastlines. Such impacts could also inject massive amounts of dust into the atmosphere, blocking sunlight and causing a global winter. Even more profoundly, significant impacts could trigger volcanic eruptions on a massive scale. The Earth's crust could be perturbed, leading to widespread geological upheaval. This increase in impact events would represent a return to the early, more violent days of the solar system, a time before Jupiter had fully established its protective role. The absence of Jupiter would unleash a torrent of comets from the Kuiper Belt and the Oort cloud too. These icy bodies, typically held in distant, stable orbits by the combined gravity of the Sun and the outer planets, would also feel the ripple effect. Some would be nudged onto paths that intersect with the inner solar system. While asteroid impacts would be a constant threat, cometary impacts, though less frequent, would be far more destructive due to their higher speeds. These icy cannonballs could deliver blows of unimaginable force, capable of causing extinction-level events. The quiet skies we take for granted would become a shooting gallery. Beyond the immediate increase in impacts, the long-term effects of Jupiter's absence would be even more profound. The delicate dance of the planets around the Sun would become chaotic without its primary conductor. The loss of Jupiter's stabilizing gravitational pull would unravel the cosmic order. This instability would particularly affect the inner planets, Mars, Earth, and Venus. Their orbits, once nearly circular and predictable, could become erratic and highly elliptical. Over geological timescales, these planets would experience significant deviations from their current paths. Such extreme orbital shifts would have devastating consequences for any planet, especially one supporting life. A planet drifting too close to the Sun would experience scorching temperatures, boiling away oceans, and sterilizing its surface. Its atmosphere would be stripped away by solar winds. Conversely, a planet flung into deep space would face an opposite but equally grim fate. It would quickly freeze solid, becoming a desolate, ice-bound wasteland. All surface water would solidify, and any remaining atmosphere would either freeze or dissipate into the vacuum of space. For Earth, these orbital changes would lead to global climate and seasonal disruption on an unprecedented scale. Our seasons, currently dictated by the Earth's axial tilt and its elliptical orbit, would become utterly unpredictable. The planet's climate would be thrown into complete disarray. Periods of intense heat and prolonged cold would become the norm. The stable temperatures required for life to flourish would vanish, replaced by wild fluctuations. This instability would make sustained agriculture impossible, disrupting ecosystems and ultimately threatening the very survival of complex life. The Earth's axial tilt, which currently gives us our seasons, might also become unstable. Without Jupiter's gravitational influence providing a long-term stabilizing effect, Earth's tilt could vary wildly over millions of years. A greatly increased tilt would mean more extreme seasonal differences. Conversely, a very small tilt would eliminate seasons altogether, leading to vast polar ice caps and potentially uninhabitable equatorial regions. This delicate balance, which Jupiter subtly helps to maintain, is fundamental to Earth's climate and its ability to sustain diverse forms of life. The solar system would eventually become a collection of rogue worlds, each charting its own unpredictable course. From a scientist's perspective, the disappearance of Jupiter would initiate a cascade of devastating events. The immediate and most apparent threat would be the increased asteroid and comet impacts, which would begin to accumulate over millennia. These impacts alone would make long-term survival for complex life significantly more challenging. However, the long-term effects on planetary orbits and global climate are considered far more devastating. While less dramatic in the short term, the gradual destabilization of Earth's orbit and tilt would ultimately render the planet uninhabitable. It would be a slow, inexorable march towards planetary chaos. This thought experiment starkly highlights the solar system's delicate balance. Every major body, especially the gas giants, plays a critical role in maintaining the gravitational equilibrium. Their absence creates a void that profoundly affects the stability and habitability of all other worlds. This scenario serves as a powerful reminder of the interconnectedness of our cosmic home. It underscores the vital role that distant giants like Jupiter play in protecting Earth and maintaining the conditions necessary for life. We often take the stability of our planetary system for granted, but it is a complex and finely tuned machine. Jupiter truly is our silent guardian. Its immense mass acts as a cosmic bulwark, deflecting danger and stabilizing our orbital clockwork. Its presence is a testament to the universe's intricate beauty and the powerful, unseen forces that shape our existence. The study of such hypothetical scenarios deepens our understanding of planetary dynamics and the prerequisites for life. It pushes us to appreciate the subtle yet profound influences that govern our solar system. Jupiter's existence is not merely a cosmic accident. It is a fundamental pillar of our cosmic order. If Jupiter vanished tomorrow, the solar system wouldn't scream or shatter. It would drift, slowly, quietly, toward chaos. And from Earth, beneath an unchanged sky, we might not notice anything at all until the consequences finally arrived.